Hi everyone, in this video we're going to be discussing tabular multiplication for polynomials. So ideally you do this before we talk about division because our multiplication process will help us a lot with division. So to complete this as extra practice and get credit for it, make sure you have your name on it. We're going to do notes on the front side of this handout, and then on the back side we're going to have, you'll have 4 practice problems that you can check with your intervention teacher after you've gone through them. So let's get started. Tabular multiplication is one way to multiply polynomials. There's more than one way. I'm going to show us this way. You may feel comfortable distributing. Here's what you do if you're distributing. You kind of just combine each term with each of the others. And so in this case, you'd be doing 6 different multiplications and then combining like terms afterward. I'm going to show us the tabular way, which is a little bit more organized in my mind. It also helps us with our division later on. But if you feel comfortable distributing, you're always welcome to do that. So the first step for this process is we want to make it, our goal is to make a table. So we're going to want to make sure we have any missing pieces we might need filled in ahead of time. So looking at this, step 1, we're going to fill in missing terms. So looking at our first term, the highest is an x squared. Normally after x squareds we expect to see an x and then a constant. So in this first term we have our x squared, we have our constant term of -3, but we do not have, we're missing our x term. So I'm going to fill in and rewrite it with that term filled in. X squared plus 0x minus 3. I just added in that missing term there, and that's still being multiplied by x squared plus 3x minus 1. So we have our missing terms. Next we need to figure out how big our box is going to be. So step 2, how big will the box be? Question mark. And looking at our terms here, the first term has 3 parts, and the second term has 3 parts. So initially it's going to be 3 by 3. Another way to think about that would be to think of the degree of each term plus 1. So the degree of our first expression is 2, so 2 plus 1 would give us 3. The degree of our second expression is 2 plus 1 would give us 3. So you could either just count the terms in both of your polynomials, or you could look at the degrees of each and add 1 to it. All right. So now we're ready to make our box. We just need a 3 by 3 box. That'll be square. And a multiplication problem is a lot like finding the area. So what we're going to do is take each of our pieces, and I'm going to highlight them. This first one in yellow, second one in pink. I want to take our yellow term and put it along the top, and our pink term and put it along the side. So that'll be x squared here, 0x minus 3, and then x squared here, 3x, and minus 1. Now notice we could have set this up a couple different ways. We could have put the yellow term on the side and the pink term on top. It doesn't actually matter how it goes in, as long as we have all of our terms like squared and x and 1, squared and x and 1. As long as we have both top and bottom filled in, now we're ready to make our products. So I'll do the top left first. Right here, we multiply each piece to get there. So x squared is in our row over here, x squared is in our column over here. I multiply them. I'll make a little note of that. X squared times x squared. That's a total of x to the, there's 1, 2, 3, 4 x's. So that's x to the 4th. Great. Now we just do this for each of the rest of the boxes. So if at this point you feel comfortable multiplying and you'd like to go through and try them out on your own, just pause the video, go and multiply each row and column to get your terms in the boxes, and then check yourself as we go back through. So if you've done that, great. Otherwise, I'm going to go ahead and start filling them in. So this one is 0x times x squared. That's going to be 0x cubed, because that's 1, 2, 3 x's being multiplied together, so that's x cubed. And the 0, there's 0 of them. Negative 3 times x squared. That's just negative 3 x squareds. Down in the next row we have x squared times 3x. That is 1, 2, 3 x's being multiplied together, so it's going to be some kind of x cubed term, and then it's like 3 times 1, so 3x cubed. Alright, for the next one we have 0x times 3x. So for the numbers, 0 times 3 is 0. X times x, that's 1, 2 x's being multiplied together, so that's x squared. So right, we have negative 3 times 3x. Negative 3 times 3 is negative and positive is negative. 3 times 3 is 9. And then our x, so negative 9x there. We'll just go down to our last row. X squared times negative 1. That is just going to be negative 1x squared, or just negative x squared. Next we have 0x times negative 1. So the numbers 0 times negative 1 is 0. And then there's our x. Last one is negative 3 times negative 1. And that is just going to be positive. Negative and negative is a positive 3. Alright, so now we've filled in all of our terms. And let's see how many multiplications we did. So we did 9 different multiplications here to get these 9 squares in the boxes. Now I just need to total all of our like terms. So the reason we added this missing term originally is so that we can nicely total up all our terms diagonally in this box. So looking at the top one here, x to the 4th, I'm just going to pull it down. There's only one x to the 4th power in all these boxes, so there's no other like terms to combine it with. So I just pulled that one out. But the next two, these next two diagonal boxes, 0x cubed and 3x cubes, those are our x cubes, so those are like terms. We need to combine them. We need to add them up. There's 3 from the lower box and 0 from this upper box. 3 plus 0 is just 3x cubes. And we can total also diagonally across these 3 squared boxes. These are where all our squareds live. Squared, squared, squared. Negative 3 and 0 and negative 1. Well, if I have negative 3 and then I take away another one, that's negative 4. So that's negative 4x squareds. Diagonally, negative 9 and 0, well, that's just negative 9x. And then our last one, that's our only constant term, so it's just 3. So in the end, the result, the product of multiplying our original polynomials, the yellow and the pink, is what we get after we combined all our like terms by totaling the diagonals. So that would be our solution down here. X to the 4th plus 3x cubed minus 4x squared minus 9x plus 3. Right. So let's try this again. Here's another example down here. In this example, our terms are a little bit smaller. I'll highlight them with different colors. There are 3 binomials. To break this down, though, it actually looks to me like this is 2 separate multiplication problems. I see a multiplication between the orange and yellow, and I see a multiplication between the orange and pink. So what we're going to do is split it up into 2 problems, sort of practice our skills. So first we're going to calculate x plus 1 times x minus 2. So just these first 2 terms, the yellow and the orange. Then, after we have our result from that, we'll multiply our result by x plus 3. We could have done any order of these. I just chose these because they're right next to each other to start. Great, so we're going to do these two to start. We need to fill in any missing terms. Our highest power in each of these is 1. So normally we expect x and then a constant, x and then a constant. We're not missing any terms with these two, so we don't need to fill in any one. So step 1 is check. Step 1, check. Step 2, we need to figure out the size. I'll just count these. It looks like we have 2 terms in the first one and 2 terms in the second one. So the size of our box is going to be a 2 by 2. Step 3, we just got to plug in and multiply. All right, so let's make a 2 by 2 box. I'm going to put yellow on top again, orange on the side. Fill in my numbers, x plus 1, x minus 2. I'm going to do our products without the notes this time. I'm just going to work from the top left. X times x times x is x. That's 2 x's being multiplied, so x squared. 1 times x is 1x. Down on the bottom left, negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. Now I recognize I did that pretty quickly. If you feel like you need to slow down and check it, that's fine. Pause the video, slow down. There's no rush on these. And then now let's total our columns diagonally. Total from the squareds, there's only just the x squared, so that's that. Total from here is a positive 1 and a negative 2. So it's like I have 1 and I took 2 away. So there's a minus 1x left over, and then a negative 2. So that's our result from the yellow and orange being together. Now I'm going to highlight this result in, whoa, that's too dark. I'm just going to highlight this result in a different color, a new one. I'll make it blue. So I'm highlighting this blue result, and now we're going to rewrite our original expression with it plugged in. So now we did x plus 1 times x minus 2, and we got x squared minus 1x minus 2. That's now our new blue term, but we still need to multiply it by x plus 3, our pink term. Great, so let's do our steps real quick again. Step 1, see if there's any missing terms. We have an x squared, an x, and a constant, so we're good. There's no needed terms there. An x and a constant, we're good. There's nothing missing in between. The size of our box, I see, let's do our degree this time. So this first one has a degree of 2. We just got to add 1 to that. 2 plus 1 is 3, so we should expect 3. There are also 3 terms. We're into 3 terms, so the size of that box needs to be 3. For this one, we need to have, this is degree 1, so 1 plus 1 is 2. Also, we could just count. There are 2 terms. So we need a 3 by 2 box. Let's make it over here. I'm going to make it upright like this time. My 2 terms have to go on top, so I'm going to put pink up there. And then my blue, I'll put on the side. X plus 3, x squared, negative 1x, and negative 2. I'm going to do these products pretty quickly. If you'd like to do them yourself first, go ahead and pause the video, multiply them out, and then just check your answers with me at the end. So go ahead and do that if you'd like. Otherwise, I'm going to go through them quickly. X times x squared, that's 3 x's being multiplied together. 3 times x squared is 3x squareds. X times negative 1x is negative x squared. 3 times negative 1x is negative 3 for our numbers, and then also an x. X times negative 2 is negative 2x, and then 3 times negative 2 is negative. 3 times 2 is 6. We total these. X cubed is the only cube term. For the squareds, I have positive 3, and then I have take away 1. 3 take away 1 is 2. For the x's, I have a negative 3, and then take away 2 more. Negative 3, negative 4, negative 5. Negative 5 x's, and then negative 6. So overall, this would be our final answer to this problem. We took our original multiplication problem of 3 terms being multiplied together, and we simplified it to just be one polynomial in standard form. Great. So hopefully these walkthroughs will be helpful. Look back to them on your notes. So hopefully you've taken notes as you've gone through this. Look back to them as your notes as you go on to answer the next 4 questions. 1, 2, 3, 4. And let's summarize our thoughts here. So for a summary, we always did our first step. Step 1, we filled missing terms. Step 2, we determined the number of rows and columns, and the number of columns. And you could either count your terms or use the degrees like we did. And then step 3 is make the box. And I'm going to call it, sometimes I call it a box, sometimes I call it a table, the box or table, and fill in values. And then I guess actually our last step, our sort of step 4 that we didn't mention before, was to combine our like terms. And we did that diagonally. Right, just like in this above, these blue arrows going diagonally. I'll go over them again in black. That's how we were able to tally up our like terms. Great. So go on and try out these 4 problems. Your intervention teacher will have a solution key. Once you've checked on them and gotten your questions answered, you are all set to show that you did some extra practice multiplying using tabular form. All right, see you next time.